Hello, today we are going to learn about the three different types of systems. So let's see what they are. The first one is a system that has no solutions. So if the system has no solution, that means that the two lines would never ever cross when you graph them. Then the second one is one that has one solution. This is one that we see very commonly, and this is when the two lines would intersect at one point. And you would write down what the x value is and what the y value is, or whatever the variables are if there's different variables. And the third one happens when there's many solutions. This happens when you graph something and it's the same exact thing graphed. So you'd have one and the same thing is graphed on top of it. That is many solutions, because since it's the same exact graph, it crosses many, many, many times. So that's just a little review. In the last lesson, we were learning how to graph these. Now, we are going to learn how to solve them using algebraic methods. So, our learning objective is I can find the solution of a systems of equation by using the substitution method. All right, let's look into it. What is the substitution method? Another method besides graphing to solve a systems of equations is by the substitution method, where we solve one of the equations for one variable, and then we substitute the result into the other equation to solve for the other variable. Think of it as like you ever had a substitute teacher. When the regular teacher is gone, you get the substitute or replacement teacher in his or her place. It is the same basic idea here with systems. One thing is taken out, so you're going to take out one of the variables, x or y, and then you substitute or replace the other thing in its place. So, let's look at this example. If I have this basic equation, y equals 2x plus 5, and then I'm told that x equals 1. I'm already told one part of my answer. I'm told that x equals 1. Now, in order to finish this, I would have to replace the x with 1, since that's what I know x equals. So that would leave me with negative 2, parentheses 1, plus 5. And then if I do the math, negative 2 times 1 is negative 2, plus 5 gives me 3. So my y value is 3. And this is just an example of it graphed. If you were to graph it, you would start at 5, and then you would go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and you would connect the points, and you would get that purple line there. And then if you want to graph x equals 1, you would look for the point x equals 1, which is to the right one, and you would make a line through it. And this is our solution to the systems right here, which is the point 1, 3. So sometimes in the regions, they'll tell you have to do it algebraically, or you have to do it graphically, or sometimes they won't tell you at all, and you get to choose which way you want to do it. All right, let's look at the next question. All right, we're going to try this simple example. Y equals 0, and we also have the equation 2x minus y equals 16. So we're going to replace our y with 0. So we'll have 2x minus 0 equals 16. You could just cross off the 0 or think of it like you're adding the 0. That would leave you with 2x equals 16. Divide both sides by 2. We get x equals 8. So we just found that x equals 8, and we were already told that y equals 0, which means that our answer is 8, 0. Because we're always going to put the x first, and then we're going to put the y. And how do we check our answer? We don't want to just submit an answer without knowing if it's true. So we can I'll take the harder equation, the 2x. Instead of x, I'm going to put 8 minus y. My y is 0, equals 16, we hope. We don't know right now, so I'm going to put a question mark. 2 times 8 minus 0 is definitely 16. So 16 equals 16. Good job. All right, so this is our final answer. Let's look at the next one. Solve the following systems of equation. So we are told that x equals negative 1. This is golden. Usually we're not told that. But remember, we're going to write our answer as xy, and we already know that x is negative 1, so we need to find y. Please pause the video and try this on yourself. This should be individual practice. So we would rewrite the equation 3. Instead of x, I'm going to replace it with the negative 1 minus 4y equals negative 5. 3 times negative 1 is negative 3. bring down the negative 4y equals negative 5. Now I don't want the minus 3, so I'm going to add 3 to both sides. I will get negative 4y equals negative 2. Divide both sides by negative 4. I get y equals 1/2. And again, how do we check our solution? We're going to use the longer equation. Usually you could use either, but because one of them here only talks about the x, we want to talk about both variables, so we use the first one. And that is saying 3x we know is negative 1 minus 4, y is 1/2, and we got to see, does it equal negative 5? Let's see. 3 times negative 1 is negative 3 minus 4 times 1/2. And that would give us negative 5, which negative 5 is equal to negative 5. So we have the correct answer. This is our final answer. We were already told that x equals negative 1, and we were able to find that y equals 1/2. All right, good job. Let's look at the next question. Now, the substitution method. Today, we are going to be solving systems of equations where we will get both of them to say x equals, or we will get both of them to say y equals. This is not the only way that you have to do the substitution method, but for today's way, we're going to get both equations to say x equals or both to say y equals. You normally know which variable to use by you look for whichever variable has a coefficient of 1. When the variable has a coefficient of 1 or maybe even negative 1, that makes it a lot easier to translate the equation into x equals or y equals. Once we have them both as x and y equals, we could set both equations equal to each other and then solve. We'll basically be solving an equation that has variables on both sides. All right, here is an example. We have these two equations, y equals 2x and y equals negative 4x plus 11. All we are going to do is, this is our first thing that we were told, it's already in y equals form. Now, we are going to take this second equation, but when we see y, we're going to cross it off, and we're going to put what the other equation tells us that y equals. So we will be left with 2x minus 7 equals negative 4x plus 11. Hopefully you remember how to solve equations. We like to bring our variable to the right side. So instead of minus 4x, we're going to add 4x. That will give us 6x minus 7 equals 11. I don't like the minus 7, so I'm going to bring it to the other side, which would be adding 7. I will get 6x equals 18. Divide by 6 on both sides. I get x equals 3. Alrighty. Now, that's good that I have what my x equals, but I also need to find what my y equals. So now, you can use either equation. Here we just chose to use the first one. And you are going to replace the x in the equation with the 3, since that's what we found what x equals. And that will let us know that y equals negative 1, leaving us with that 3 is x and negative 1 is y. And just like before, we could check this by going to one of the equations and plugging in what we know. This equation was y equals, y became negative 1, negative 4x, x became 3, plus 11. And if we do it out, both sides are equal, so that is definitely our solution. That might have been a little confusing for you just to follow along with whatever was written there, but now let's do this next problem together. All right, first thing we're going to do is get both equations to say x equals or get both to say y equals, which luckily here, both of them do say y equals. So we're going to set both of these equal to each other. We're replacing the y here with what y is equal to. So we will get 2x minus 10 equals negative 4x plus 8. I don't want the negative 4 here, so I'm going to add it to the other side. 2x plus 4x is 6x. Minus 10 equals 8. Now instead of minus 10, I'm going to add 10 to both sides. And I will get 6x equals 18. I want to get rid of the 6, so I'm going to divide both sides by 6, and I have x equals 3. All right, that is really good that we know what x equals. Now we need to go find what y equals. So use either equation. I usually just use the first one. Y equals 2x minus 10, and we are going to replace the x equals 3. So we will have y equals 2. Instead of x, let's put a 3, minus 10. 2 times 3 is 6 minus 10 is -4. So y equals -4. So our final solution is x is 3 and y is -4. I never ever want to just submit this answer because if it was wrong, I'd feel really sad that I didn't try checking it. So I'll use the second equation here since I haven't used that one yet. Y equals -4x plus 8. Y is -4, hopefully equals -4. X is 3 plus 8. And let's see if this works. -4 times 3 plus 8 is -4. -4 does equal -4, so we are good. You could also be double, triple sure that it's correct by also using the first equation and checking it there. Y is -4, hopefully equals 2. X is 3 minus 10. 2 times 3 minus 10 is -4, so we are good. -4 does equal -4. Meaning that our answer is definitely 3, -4. All right, good job. Let's look at the next question. I want you guys to pause the video and try and see if you can figure this one out. All right, we are gonna we have that x equals 3, y minus 11, and we have another x here. We can just replace it with what we know x equals. So we'll have 3y minus 11 equals -3y minus 14. I don't want that minus 3 there, so that minus 3y there, so I'm going to add 3y to both sides. That allows me to get it to have variables on just one side. 3y plus 3y is 6y, minus 11 equals -14. I just want to let you guys know, since both of them say x equals, that's why we were able to set them equal to each other. Even if you reverse the order and put the left side equal to the right side or the right side equal to the left, it's not going to make a difference. You will get the same answer. All right, let's add 11 to both sides. I will get 6y equals -3. Divide by 6 on both sides. Y equals -1/2. Now, we need to find what x equals. So I'm going to go to the first equation. Doesn't matter which one, I just go to the first one, which is x equals 3y minus 11. So x equals 3. Instead of y, I'm going to put -1/2 minus 11. So I have x equals 3 times -1/2 minus 11. I get -12.5. You could either write it like that or you could write -25/2. Doesn't matter. I'll just keep it as a fraction, so they're both fractions. So our final answer is -1/2, comma, oh no, my x first. My x is -25/2, comma, my y is -1/2. Good. And I love to check my answer. So let me use the second equation that I haven't used yet, which is x equals -3y minus 14. X we found is -25/2. And we need to see, is that equal to -3? The y we think is -1/2 minus 14. Let's see. -3 parentheses, -1/2. X, that's our x. No, that's our y, minus 14. And we get definitely -25/2. So they're equal to each other. So this is correct. And you could be double sure by also using the first equation and plugging that in and seeing is it good. X is -25/2, maybe equals 3. Y is -1/2 minus 11. And let's see when we type it in the calculator. They are both equal to each other. So this is 100% the answer. Check. All right, good job. Now let's look at this word problem. This word problem says, the sum of two numbers is 17. So I'm going to have x as my first number and y is my second number. First number being the smaller one, second one being the bigger one. All right, the two numbers, the sum is to add. So I have x plus y equals 27. And then it says the larger number, my larger number is y, is means equal, 3 more than means to add, the smaller number is x. Good. So now I need to get both of them to be, what do I need to do? I want to substitute by getting rid of this y and putting what y equals. Here I know that I might think that y equals 27, but it's x plus y equals 27. So I need to get rid of that x. I'm going to subtract x to both sides, and I get y equals negative x plus 27. Now this is what y equals, and this is what y equals. And we can set both of those equal to each other. So I would have negative x plus 27 equals 3 plus x. Or you can do it the other way around, it doesn't matter. I'm going to subtract x to both sides. I'll get negative 2x plus 27 equals 3. Subtract 27. I get negative 2x equals negative 24. Divide by negative 2, x equals 12. That's great that I know what x equals. Now I also need to know what y equals. I'll use the equation that literally says y equals. Y equals 3 plus x. So y equals 3 plus my x is 12. So y equals 15. So I would have 12, comma 15. Let's see if both of these are true. Are the sum of them 27? Well, if I add the two together, it does equal 27. And is the larger one 3 more? Yeah, the difference between 12 and 15 is definitely 3. So I like my answer. All right, now we're going to look into those special cases. We could have something called inconsistent systems. An inconsistent system consists of parallel lines. Parallel lines are lines that look like this, where they have the same slope, so they're rising and running at the same amount. And because of this, they are never going to intersect. They're never ever going to cross each other. When searching for a solution to an inconsistent system, you will end up canceling out the variables and coming up with a false statement where two numbers equal each other, but the numbers are not actually equal. It's false, leaving us with no solution. So let's try this example right now. In order to do this, I want to replace my x, and I can only do that by getting this second equation to say x equals. So I need to get rid of the 2y by subtracting 2y, and I'll get x equals negative 2y plus 13. Now I'm going to set this part to this because x equals x. So 9 minus 2y equals negative 2y plus 13. All right, I want to get that 2y to be on the left side, so I'm going to add 2y, add 2y. Negative 2y plus 2y is 0. So that crosses off, and negative 2y plus 2y is 0. So 9 equals 13? I don't think so. That's false. So when you end up with no variable and a false statement, we say no solution. And let's look at the next one. Dependent system. A dependent system consists of the same lines that have the same slope and the same y-intercept, so all the numbers are the same. When searching for a solution to a dependent system, you will again end up canceling out the variables, but you'll end up with two constants that are equal to each other, making the statement true. And because it's true, that means we have many solutions. So let's look at this example problem. I see that this one says y equals, so I want the bottom one to say y equals. So I'm going to subtract 6x. That would give me negative y equals negative 6x plus 2. Divide both sides by that negative 1. We'll see tomorrow there could be another way to do this because maybe we don't want to do that extra step of dividing by 1. But for right now, this method looks perfect. So but we got this equation to say y equals this, and we got this equation to say y equals this. All right, let's set them both equal to each other. 6x minus 2 equals 6x minus 2. Right off the bat, I see that they are the same exact thing. Let's look what happens here. if I bring this 6x over, I would subtract 6x, subtract 6x. That gives me -2 equals -2, which is true. And when it's true, that means we have many solutions. Perfect. Alrighty. And now let's just do a quick rapid random regents review. The formula for the surface area of a right rectangular prism is area equals 2 length W plus 2 height W plus 2 length H, where length is L, W is width, and H is height. Which term in this formula is not dependent on the height, which means which one has nothing to do with height? This and this one definitely have something to do with height because I literally see my height there. This one seems like a good answer because there's no H here, but let's look at A. What does A represent? Well, A represents 2LW plus 2HW. Oh, look, right away I have an H there, no good. 2 is the only one that has no H present, so 2 is your answer. And that wraps up our lesson on how to solve systems using the substitution method, where we were making the x and y both equal to each other. And tomorrow we will learn another way we can do substitution method for when it's not that easy to make x and y equal to x equals and y equals in both equations.